So your typical, what you use term stress strain diagram is actually a load versus elongation diagram. The rest is derived, correct? Load is being put, you're getting kilonewton, whatever is the load, and you're getting elongation. Machine converts it and says this is the stress strain diagram. Okay. So what does it look like? Okay. Yes or no?
Yes, yes.
Okay. So now let's tell what is what? What is that point?
Yield point.
Yield point. What is this point?
Upper yield point, lower.
Be specific when you talk to me. So this is the upper yield point. This is the lower yield point. Okay. Now this is very clear. So if I want to find the yield point, I can just measure up the load over here and say yield stress is so much. Now I come over here. What is this point?
Ultimate
Ultimate load. Maximum.
Maximum.
Ultimate is here, no? It broke here. Right or wrong? This is the maximum load. This is the breaking load. Now, how come it broke at lower load than the maximum load? It has broken here, no?
Elongation due to elongation.
Due to elongation, so what? Elongation is here.
It's plastic deformation happening.
What?
Plastic deformation.
Plastic deformation started from here. Happening. Then what? It stopped happening.
Final yield strength.
Pardon?
Final yield strength.
This is the yield strength. This is plastic deformation. It will not come back now to original shape. Anywhere up to here, it will come back to its original shape size. But the moment it crosses the yield and goes here, it will not come back to the original. It is permanently deformed because plastic deformation has started. Now my question is not that, we can come to all that. Here I got a load value. Then I found that the load is falling and then it broke. So why did it have to fall to break? Why did it not break here?
Ductility.
Ductility is there. Never asked the question to anybody why it didn't break. Okay, that's your sample. Round section. Having diameter of whatever ½ inch or anything, standard sample. Now this whole calculation, what we are doing, is based on load with original cross-section area. Moment you start pulling this is actually falling. Okay, maybe falling slightly or not so slightly. At the point over here, what is happening? The neck is beginning to form. Now, what is the neck cross-section area? Much less than this. So even though the load is falling, the stress is going up because it is load by actual CS area. But the CS area is not that of ½ inch, but maybe of ¼ inch. So the load has gone up. I mean, the stress has actually unlike that. But you are measuring it as a load by original cross-section area, which is wrong. Because of the neck portion and the final fracture, the stress went up and therefore it broke here. This is only our false.
People are not able.
No, but
Sir is explaining.
there's a camera there, or
No camera, sir.
then how will they see what I'm saying?
Like this.
Okay, okay, okay. So load by actual, that is called true stress and true strain. What we are talking is engineering stress, engineering strain. Load by original cross section, load by actual. Instantaneous load by instantaneous surface area. That is the reality. This is a simplification. Load by original cross section area. Okay, that was by the way. The real question is not that. Real question is that what is 0.2% proof stress? So this is your one type of load elongation diagram. This is good for carbon steel and all those theoretic materials. When we go into austenitics, then the diagram changes slightly, and what you get is like this. Now there is no definitive yield point over here. So what is my yield point? So I take a line over here, which is equal to 0.2% of strain. And I draw a line parallel to this. And wherever it hits, that is my yield, 0.2% proof stress.
This is which point, sir? Point of
Which
where
one?
it is meeting.
This is the load versus elongation diagram.
Stress strain, huh?
Yes, that's true. But it is of this shape, it is not showing the knee type of yield. Stainless steel. The diagram will be like this. So where is the yield? So I have no yield. So I have to take a line at 0.2% strain, draw parallel to this line. Wherever it intersects, I read off the yield load. Then I do the yield stress, 0.2% proof stress.
So this one strain, huh?
Which one?
Strain.
This is strain, this is stress.
So why we you 0.2%?
It has become a standardized thing somewhere nearest to what would have been the yield. There's 1% also, depends. Some people are allowing you 1% line also to take over there.
Sometimes normally.
Depends on the spec, 0.5%, 0.2%, and 1% also. Because the designs which are based on yielding, he gets benefit by taking a higher. The yield is going higher as per this graph. So if I allow 1%, it will go and touch over here, which will be a higher value. So yield by 1.5 is my allowable, by the way. Yield by 1.5. So if my yield I have allowed to go up, yield by 1.5 has gone up. So my thickness has gone down because my allowable stress has gone up.
This is applicable for SS only, no?
Typically you will find this type of curve in SS materials. Carbon steel will give the knee. So you get a definitive yield point. So no need for any 0.2% or anything like that. So this is 0.2% proof stress. What else you want to know? What are the stages to perform inspection of pipes? You tell me. Material inspection. You can't get traceability. You have to just go by paperwork. No? You can't have a marking transfer on the raw pipe to the finished product. Then he will do his extrusion and make the pipe. Hydro test and dimension. Finish. What else can there be? Baki's paper trail has to be there that the same heat of material got processed into this size of pipe. That is only by paper. Then he marked it correctly or not, that you have to obviously check he marked it. And surface finish, eddy current testing, hydro testing, all those NDs. In lieu, they say eddy current in lieu of hydro test. I don't agree. So the code allows it. If you're going to be a heat exchanger tube, it should be hydro tested because when it leaks, in fact, eddy current past tubes also have leaked. And what will you do? 1,000 tubes are there and the middle tube has leaked. Sit and block it. What else will you do? But that is a type of problem that comes. And he will say that, oh, if you take eddy current, I'll give you tomorrow. If you want hydro tested, I will give you after 1 week. So everyone will say, okay, give me eddy current testing, destructive testing. But it's not the same thing, especially if your job is critical. These all conveniences given under pressure of manufacturers. Why not? Why not? Why not? What is there? See, I'm proving it to you. This is the case. He'll bring some big document saying that if it's eddy current is okay, the hydro test will pass. Maybe, maybe not. But once you have hydro tested it, you are sure that it is okay. How to define a pipe by NPS or NB? NB is nominal bore and it was the older way of saying. NB 12 inches. When you say NPS, it's nominal pipe size and you will only say 12. You won't say inches, millimeter, or anything. It's just terminology change. But they are encouraging use of NPS more than NB now. What is the reduction of area and tensile test? You tell me. Now you tell me. What? You don't know.
This is the area, original area.
After necking and break, the difference divided by the original area, that is a percent reduction of area. That is wherever is required, you have to provide that data. So that is okay, also clear, reduction of area. Difference between BHN hardness and Vickers hardness test, they are two different methodologies. They have an equivalence, but those have been determined for each steel. It is not necessarily that the table is common for any steel. When he says for carbon steel, if your BHN value is so much, equivalent Vickers hardness is so much. You have to go by that table only for the material. Basically, the indenter, which is what is hardness? You have got an indenter. Okay, it may be a ball or it may be a needle type of something like that, diamond shape, pyramid shape, whatever it is. So the penetrations are going to be different depending upon the shape of indenter. For the same load, the ball will indent less and the pyramid shape will indent deeper. So it gives you a different reading for the same this thing based on depth of indentation and the size of the indentation that has been produced. Basically, we are measuring the dia of the indenter, indent made on the material by the ball. So that is an average value over the size of the ball which has been indented. The Vickers one has a pyramid which is much smaller, which will give you more of a localized. Not that this is not localized, but it is bit broader, that is bit smaller. So if you are doing hardness of a heat affected zone of a weld, you don't want an average figure of the whole HZ, do you? You want to know the different zones of the HZ, and I want to understand the hardness fluctuation between the different zones or the different phases. So there is micro hardness tester also. That's called a loop hardness. There is because micro hardness. Each phase I can look that this is my austenite or retained austenite or ferrite or cementite or pearlite, I can check the hardness of that phase. Now, I don't want to do it for normal purpose because the normal spec says hardness should be so much. 22 because HRC, HRB, whatever it is for the SAR service or anything like that. So you go by what he says that this is the method and this is my hardness required. If you wish to convert for any reason, then look at the appropriate table. But the methodology is being different. It's just a different development. He made a Vickers fellow, made an indenter, which said is very good. The Brunel fellow made an indenter, he said that is very good. Each one thinks he's very good. I have used the Noop hardness tester on how much? 1 gram, 10 gram load, just to find the hardness of the phase under microscope of 100, 200 magnification. Those things are different. We don't need to do in normal work, that was research work. Now we are talking of bulk hardness, average hardness over certain small area.
So, I have a question regarding hardness.
Yeah,
Suppose there is a piping weld, right?
yeah.
So general perception is that on the weld area, the hardness should be more. Then HHZ it should be lesser than the weld area, and this metal it should be less as compared to. But while taking hardness, no, it is on field area, no,
Yeah.
it differs mostly. Sometimes HHZ area hardness coming more than weld area.
No, but tell me firstly that you are taking the hardness on a finished weld,
Yeah,
not on the cross section.
yeah, finish weld.
If you take in the cross section of a test weld, that will give you the true values. And mostly HSZ hardness is more than weld hardness. For the simple reason that the carbon is always higher in HSZ than in weld. Now, when you're doing weld with a crown, you have made some flat surface on it, or whatever you have done, that can be variable. And you're using that rebound tester or what? Yeah. So that is very sensitive to the surface finish, and also slight angle change here and there makes a big difference in the value. That rebound testing is a very difficult thing to use. I found problems with the surface finish. Little bit of scratches are more or less, it makes a totally different value. So those things I have no answer really. But the basic concept is HSZ, the base metal, HSZ, weld, HSZ, base metal, like that. That is the norm. How to calculate hydrotest pressure for pipes? I thought it's there in the spec. No. Hydrotest pressure for pipe. We have made a pipe. I want to calculate the hydrotest pressure for the pipe. That is it, the pipe spec. We are talking fabrication. Now you have got a pipe that was hydrotested at its pressure. You may use it at the same or lower pressure. That is your design. But that value is in the spec of the pipe. I think you can find it. But I don't remember, but I know it's there. How to verify if impact test specimen is correct? How to verify if impact test specimen is correct? It's a question. Yeah?
We go to ask for 370.
Question is how to verify that the impact test specimen is correct.
Yeah,
You're checking.
optical projector.
Yeah. Yeah,
V group
yeah. And
sizes
Size dimension.
check
according to job thickness and specimen thickness
and
and temperature.
and There is specimens when I know temperature. Specimen is correct or not? That is if the testing is correct or not.
No.
Question is the
Sizes
specimen?
and after V group,
Yeah,
and then next
Shadow graph is
temperature.
there.
yeah, it's there.
So whatever you have said earlier, no, we have to confirm whether that sample is taken from where.
Yeah,
Material.
nobody thinks of that.
Yeah.
Everyone is fighting on the shadow graph. One bird is there. निकालो उसको. अरे कुछ नहीं होता.
How we can confirm, sir? Shadow graph is okay.
By measurement.
Which dimension? How? But how?
No, but you have got a magnified 50, 100 times image, no? So all your tolerances are also,
How
all
you
the
can
tolerance.
confirm that shadow graph is okay?
No, 45 degree का तुम्हारा angle है. You have to measure that it is 45 degree with a protractor, simple, nothing else.
Optical projector is
So this is
showing
so
degree.
this-
Yeah,
this is
showing degree.
interview question.
Pardon?
This is the asking interview, Reliance interview.
Okay,
Okay, how you verify that shadow graph is okay?
the
Where-
image.
Yeah.
Yeah, by measurement. Measurement. Reliance will tell him by measurement.
Is it a layout or how we can?
On the layout,
On the
on the
layout.
magnified layout.
Magnified layout we can
Yes,
check.
yes, you have to check on that only. You can't check anywhere else.
Lab also having
Huh?
optical.
Yeah, lab also. Whatever it is. So which standards for inspection of A234 that you read the A234 spec? What is the purpose of elongation in tensile test? Tell me. What is the purpose of elongation in the tensile test?
Elongation is how much elongate the material.
Correct,
And
ductility of the
strength is
material.
Maximum how much material.
Acha, tell me one thing. I hate myself. Have you read 516 spec? Anyone? 6? Huh? 516. He's saying elongation in how much gauge length? He tells no.
370 standard. ASTM standard 370.
That is method.
Testing.
Now I am talking requirement. 22%, 21% in 50 mm and 17 or 18% in 8 inch. Why? Same material, no? You have got two elongation values depending upon gauge length used, right? Now, why different? Same material. If I change the gauge length, my elongation will change.
Depends on direction.
No. Same direction, both of them. Parallel, side by side, I will take two samples. Because of this fellow. Where is that? Where does that error come? Error comes in this neck. This is the error in our calculation. This neck for the same dia, the amount of necking, let me say, is same whether this is a 50 mm gauge length or a 200 mm gauge length. So this becomes a smaller proportion of 200 and a larger proportion in 50. Therefore, I am required to measure 21% in 50 mm and only 17% in 8 inch. If I were to make this bigger than 8 inch, I would still get less because this proportion, this is the error part of the elongation. It will get lesser and lesser of the gauge length. This will keep going down. But the material is the same. It's just our perception and way of measuring that is causing the confusion. So what was the question I forgot? Purpose of tensile test. What's the purpose of tensile test?
Required to test or load.
Test of the metal.
What's the purpose? Not what does it do? What is the
For
purpose?
the strength, material strength.
Material strength.
Strength and ductility.
Yeah.
Because you're getting yield strength, tensile strength, and elongation. Three things, and reduction of area. At what temperature impact test to be done for low temperature carbon steel fitting? As per spec.
Minus 46.
You all are stuck on minus 46 for why I don't understand.
We left for minus.
That is for a particular spec minus 46. Whatever is your spec, that will be the temperature. Why should be only minus 46? What is temperature tolerance for impact testing? You don't know.
Plus minus 1 degree.
Huh?
1 degree.
Plus minus 1 degree. Yeah. But reference from where you got this 1 degree? Or 370?
370.
Which standard used for impact testing? Yeah. What the dimensions of subsize specimen for impact testing? I have shown you a figure. 7.5, 6.7, something up to 2.5. Those are the standard subsize. From where will you get the temperature for subsize specimen for impact testing? UG84, I think.
Table 1, table 2.
UG84. See, if I do something, it will cancel from here, so I don't know what to do there. UG84, the two things are there, remember. One is subsize specimen where you get the requirement, subsize requirement only. Another is aspect which is the more, I should say, of concern, that when I couldn't have taken a 10 mm specimen from my piece, I have not taken and I have taken a 5 mm specimen. Two things are there. One is my sample thickness was such that I could get a 5 mm specimen only, in which case I don't do any reduction in temperature. But when I could have got 10 and I took a 5 for whatever reason, then I have to reduce the testing temperature by a table given in UG84. Yes or no? No. Read UG84. Whereas plane stress, plane strain theories are there, a lot of fracture mechanics are involved in this. Finally, they have put it in a table that if my reduction is so much in the specimen from what I could have got, maximum, then you reduce the temperature by so many degrees to do the testing, which makes it equivalent to having done the full size specimen. What is the purpose of burst test in fittings? Tell me.
Integrity of test fitting.
Yes, no doubt. And basically, what we call in code terminology, proof test by bursting. This is, of course, part of the material spec, but when we talk of fabrications also, you can do a burst test and back calculate what will be the allowable pressure which this fitting will be good, or item, or fabrication. So that is the purpose, is to get a figure, back calculate and say now it is usable safely at this pressure and this temperature. That is the purpose of this. Test to failure, I call it. Can we use CS qualified burst test for SS fitting?
No.
It has to match the material properties, have to be matched within a small range. Yes, there is some extension possible, but I don't think this includes that range. We have to go for a similar material, similar size, similar thickness. But the burst test procedures tell you that if you qualify this, how much it can be used for which sizes or something like that. What is the difference between hydro test and pneumatic test? Hydro has pani and that has hawa.
For strain.
And
Change the strain and
Pneumatic.
pneumatics for leakage.
No. All come under over pressure testing. Nowadays, the code does not use the word hydro testing, it uses the word pressure testing. If I'm applying the same pressure, whether it is due or made by air compress or by hydraulic fluid, the effect on the job is the same. It doesn't care that air is pressing me or my liquid is pressing me. Why we are concerned about pneumatic test of any gas used for that is the failure probability. If it should fail, then lot of volume of this thing will be there, energy, and that can cause a lot of damage. Whereas in a hydro test failure, the moment the small leak happens, the hydro test, the pressure falls. So the propensity for damaging around is much reduced, which is why the pneumatic test pressure is kept only 1.1 times of design. Actually, he means keep it at design only. Otam ka 1.1 times. There he says go to 1.3 times. That is the real test. 1.3 times into allowable stress ratio into whatever it is. But because of certain requirements that you are not able to perform satisfactorily the hydro test, you are allowed as a special case to do pneumatic test. Especially on site, it's a vertical vessel, it's been installed on site and welded, everything. Now my foundation cannot take the weight of liquid. I will do a pneumatic test. Otherwise, the default test is a hydro test. In boilers, they still don't allow pressure, pneumatic, only hydro test.
Depending upon process flow also. What is going
Depends on
inside.
plant also.
That means it cannot tolerate, like liquid oxygen vessel, you are only doing pneumatic test. Because it cannot tolerate any leftover liquid. Once you have finished the test, you have to dry it. But does it mean that you have removed all the moisture or liquid? There are many trapped. But when you cannot tolerate that, then say don't put any water in my liquid, use a pneumatic test and do it.
But depends upon plant also.
Service.
No, client.
Recently, we have checked the pneumatic tank, the pneumatic test.
API tank, which tank? API tank?
Not API.
Then which tank?
Yes,
No, he is not only Vim and fancy. There are conditions given in the code under which it is permitted. And only if you are complying with those conditions in code, then you can deviate from the default hydro test to a pneumatic test. Client bolega pneumatic test karo, not just because he says. That's all I'm saying. You have to justify why.
So, I have one question. In hydro testing, suppose you elaborate that acceptance criteria with the drops, so drop leakage. That is it.
Allowable drop.
Double drop.
Sweating.
We are talking about sweating.
No drop.
No drop.
No drop.
But
then you also
Huh?
Allow.
Except in some connecting pipe you have done something, little drop is falling, he doesn't care for that. Not in the part of the vessel or its,
Well joint and.
no, well joint, no question, even in gasketed joint which are permanent, like a manhole cover is a permanent part of the vessel. Not one drop is allowed over there either.
no.
Now, vials are permitted,
That's
that is permitted, leakage is there. Through the seal. So many
All
drops,
as per standard. right?
so many drops per minute that can go. So seed leakage, yeah, that is okay. That is different. When we talk of fabricated pressure vessel, there is no leakage, no sweating, no nothing. Valve में तो he sees sweating and he hammers it and बंद कर देता, बंद हो गया. That is what. Yesterday I was repairing the tanki of my building, the syntax tank, and he left one little thing and in the evening, one nice stream of water was coming out from that. He was welding, closing up this thing. I called him again today. I am here, but my mind half is over there. Did you close that leakage or not? So he is doing the welding of plastic and plug that leakage. No leakage is permitted. I use the same rules in my building as I use in pressure vessels. Fortunately, they don't question me too much. Okay, draw what is this now? Testing required for 350 LF2 material. Now, what type of question is this? You read the spec, no? Minus 46, minus 46.
For NC, but
What is the impact test required for LF2 material? Minus 46. If impact test is required minus 196, what are the test requirements? What he means is what is the acceptance standard? Are you done? Stainless steel
API for wall,
at minus.
Cryogenic.
But what is the test requirement? What is the acceptance requirement? How many joules? Stainless steel. Don't ask me, you tell me. Is it 18? Is it 20? I don't know. Firstly, you don't measure joules for very high strength materials, and for these austenitics at minus 196, there is lateral expansion requirement. That means how much is the sample deformed when it is squeezed by this plunger. It deforms in the perpendicular direction. So that deformation is important. And that is to be 0.3 mm or whatever is the requirement given in code. 0.3 or 0.51 mm, there is a graph given. And that lateral expansion is the criterion for acceptance of impact test of stainless steel at minus 196. Joules are important. If impact tests require minus 190, okay. What are RT defects in casting? Tell me. Hot tear,
hot air,
shrinkage, slag
slag
intrusion,
inclusion, sand inclusion.
sand intrusion. So you know everything, now why you're asking these questions? Everybody knows everything. Yeah, porosity, whatever. Why do we do helium leak test?
Sometimes we do pneumatic air test.
Yeah.
Leakage can be detected by helium leak test
Yes.
through joints,
Yeah.
line joints.
Yeah.
That we can detect it.
Yes,
This is also called sensitive
But
test.
this cannot be detected by pneumatic air test.
correct. But all flange joints,
Line and stem,
stem means
Stem,
stem.
stem,
Stem.
wall stem,
Wall stem.
stem side.
so whatever it is, the helium leak test being the most sensitive
Sensitive
leak detection test, it can detect something to the power of minus 6 cc per second and things like that, which is typically used for the tube sheet joints in heat exchangers. Yeah,
It is allowable.
not for the
So
alloy
leakage-
weld. If the weld is not made properly, it will show a leakage. There must be a leak path. No? Important in all this what? That there must be a leak path from the high pressure side to the low pressure side. Helium atom can move through that path and get detected by a detector on the other side. Once it gets detected, then you find out what is the rate of leakage. Normally, moment they detect it, they stop and then they try to pinpoint from which tube the leakage is emanating and they repair that tube. No one is going into, it's okay, minus 6 is okay, but moment they get a leakage, they repair it. Because it will only get worse. That's why. So what is normalizing and what is holding temperature, you know, I think by now. Tell me.
9
And holding temperature, we never talked about.
for 25 and 1 hour.
No, that one thickness.
Depends on
25 and 1 hour.
1 inch per 1 hour. Inch per hour.
1 inch per hour is the holding time for post-weld heat treatment. It is as necessarily applied to normalizing. Normalizing, it is 1 to 1.5 minutes per millimeter. It is less, that is 2.5 minutes per millimeter. This is 1 to 1.5. But it's not defined in any code. So it is for the heat treater to give you the proposed cycle. Heat treatment for stainless steel and holding temperature.
1080. 100.
1050.
Plus
And
minus.
for solution annealing. I showed you the structure of a pure austenite and of a sensitized austenite. Now you have got sensitized, put it to 1050, hold it for how long? 1 hour per inch at least. So that all the carbides go in solution and then you quench it. And someone will say, no, I will not allow you to quench in water. I want it quenched in air. So he will put 10 fans, take it out and put 10 fans. And finally, he will find that within 5 minutes, it didn't go down. He puts water in the end to make sure that it got cooled. ASME Section 8, Div 1 clause and pressure formula for hydro test. Clause. Yes, UG 99. And formula
1.3 design pressure
into
stress.
allowable stress ratio at room temperature divided by design temperature. 1.3 into MAWP. You know the difference between design pressure and MAWP?
Maximum allowable pressure.
Difference between the two. I know what is MAWP. What is the difference between the two?
Design is some formula calculation.
Design is given to you. Design pressure.
Maximum strength.
Design pressure has been given to you, 10 kg per centimeter square. On that basis, you are going to design your vessel and determine thicknesses based on allowable stress and formula, everything like that. Having then come to a stage where you are putting the parts together, you find that some parts which you wanted so much is actually thicker. So that part has got a greater amount of pressure retaining capacity. So all those parts put together, you determine the maximum allowable pressure for each part. And the lowest of those is the maximum allowable working pressure of the assembly, which may be equal to or greater than design pressure. It cannot be less. ASME section 8 clause for dish tent. He wants you to buy her the code or what? UG 32. You didn't ask him, show me the code book, I'll find it for you. What to check in dish tent? Now this you should know.
The profile area, the height, the
Ground radius. Height, thickness.
thickness of the distance,
Dish height.
then
Cleaning.
PT
Of knuckle.
of metal from outside and inside.
After burning thickness.
Yeah,
Each
thickness,
area.
minimum thickness.
Mean,
And
yeah.
And
Template matching.
if done or not done,
Yeah.
that is not part of the distance geometry.
Template matching.
Yeah, we said template matching. And Last but not the least, most important, the identification. Identification. You lose identification, what use is it?
Ovality.
Yeah, that ovality, thickness.
We have to check the center hole also, sir.
Check means kya?
Center hole.
No, check what?
No,
Center.
check. It is there or not. Center
It
hole.
may not be there. If it's there, then
Then, if in the design, in the drawing, if there is no nozzle in the center of the descent, then we have to do the 100% RT of that.
you have to first plug it. No?
Plug, yeah, after
You have to
plugging.
put a plug and then you have to weld it and then you have to do 100% RT of that. How to check thinning in distant?
Diameter.
Diameter. How do you calibrate a diameter?
Calibrated master.
Block is
Master
there.
block is there
Which is on the machine.
on the
Yeah.
machine.
And what about using another block which is, see, the idea behind calibration is that master block is something I don't know what the material is.
With the diameter,
And you are-
masterpiece is there.
Yeah, with
Some
diameter,
instrument,
no?
yeah.
But it is one piece only, no? You can't change the piece, no? It's built into the
It is fixed on the.
I know,
diameter.
so it is one material. Now, what is diameter doing? It is sending a pulse of sound into that material. Based on the velocity of sound in the material, you are getting a correct or incorrect result. So it's not universal that put it anywhere, it will be correct.
Change velocity.
So you have to again validate it by taking a block of material which is near to the thickness
Near to
what
the-
you are trying to determine and verifying that it is still showing me, because now I can measure it.
Yeah.
So I put a micrometer, I measure the thickness, I put my diameter after doing all the calibration on the machine.
Yes.
Now I take this validation piece, put the diameter there, check is it showing correct, more, less, and make correction. Then I am sure. And the piece should be equal or near to the nominal thickness of what I'm trying to ascertain. So it should be ideally made of the same material, or we take in the skirt of the distilled. We take one reading there. And that you do by diameter, that you put your micrometer, you are okay. What is negative tolerance in flanges, PCD and fittings? What do you mean?
Tolerance at PCD.
Huh?
See,
PCD tolerance is given.
That's why we
Find it.
B 16.5.
16.50.
Yeah. Do fittings have prototype test? Maybe. They make standard fittings. They would have done a burst test sometimes. That same burst test question, this is the same thing. How to check tube sheet expansion? Bore gauge.
mortgage.
And what is expansion? What is the limit of tube to tube sheet expansion or contraction? बोलते हैं. Tube to tube sheet expansion. How much expansion?
As per code.
What code doesn't tell
3 to
anything?
5%.
Code doesn't tell anything. It depends whether you want light. See, when I got a tube and a tube holes, it has come to the picture of it that will explain better than anything.
It's go in the expansion. Why is the expansion of like full expansion? Why is it 3 to 5% of full expansion? Like, full.
So this is your,
Yeah.
this is your tube hole. This is the tube sheet. And inside I want to put the tube. Okay. Firstly, there's a clearance between tube and tube hole, which I know more or less. So I do what I call a light expansion. And I make this touch. After that, comes the next stage where I go and do more expansion, and then the thinning of this starts. And that thinning percent is what we are talking about expansion. So 2-3% makes it light expansion to touch. When you go to 6-8-10%, then it has thinned the tube. If you thin it too much, the tube will only fail. Now, what the new theory is that once you do 3 or 4% expansion, doing more expansion doesn't help in holding the tube. So you either hold it by a strength weld over here or the grooves. Those hold the tube. But if you're talking plain tube in a plain tube hole, doing more than 3% expansion or 4% will not help you in any way.
So strength
Strength weld. Still you get leak. Leak होता है. Then you do helium test. What is the acceptance criteria of tube to tube sheet joint?
pneumatic testing.
Not hydro test. What about the mechanical test, pull-out test? Because you have done some calculation which you all are not doing, I understand. But the designer has done a calculation. Suppose you expanded tube only, depending upon the whatever is there in that TEMA code, you do a pull-out test and you know what is the load that this joint can take. And if it's a fixed tube sheet exchanger, then that load is going to be having to be held by this joint because of differential expansion between tube and shell. Whichever is expanding, contracting more. They're not contracting, expanding the same amount because even the temperature is same, the materials are different. So that differential load has to be taken care by the joints, and that they're done by pull-out test. So I know by this joint can take so much load. Now, whether the designer has designed for that or not is his problem. SMA weld defects we are told, GTA weld defects we have told, WPS variables is a whole program on its own. Which tests required to qualify WPS you read in the WPS only. You need transverse tensile and you need bend and you need impact. And what's the why we need this bend test, by the way? Suppose I say side bend, side bend.
Lack of fusion.
We are assuming that the weld has been made properly. So there is no lack of fusion. We are checking compatibility between the weld and HZ, that no brittle product has been made, fails. If it has been, the bend rest will crack. See, the job is not going to be bent 180 degrees. So people have asked, why do you want to do bend test 180 degree? And this is the reason that when I bend it and if there is something improper, what they call brittle intermetallic, the word brittle. So obviously it cannot stretch. When I do bend test, what is happening? The OD is stretching, being elongated. If it doesn't have elongation, it will crack.
Yeah.
So bend test, we keep fighting over 3 mm defect. Then EL fellow will say, no, it is 3.1. Then I will fight with him. No, it is 2.9, just to see that we agree at 3 and the end of the game. But that is meaningless. If your bend test is really bad, meaning your welding is really bad, the bend test will just break into two. The specimen will break into two. All these 2 and 3 mm are due to some inclusions or slag that may have been left behind at that point. Slag has no ductility, so it will show an opening over there. And that 3 mm, and please note there is no limit on the number of 3 mm openings. No limit. Each opening shall be within 3 mm. So whatever slag pieces are there, they get taken care by the 3 mm opening. If your sample is bad, it will break into two. I have seen it happening. So you get a shock when it breaks into two.
If there are 4 to 5 opening
Chalega. All should be within 3 mm.
within 3 mm.
Within 3 mm. There is no limit on number of openings. How many tests for tensile and bend test? 2 tensile, 4 bend. Which type of bend testing is required? Depending on thickness, it may be face bend, root bend, side bend. WPS thickness qualification for with impact and without impact test. Read the code. 16 mm and above will be qualified, not 5 mm. Why again now? Go back to your thick plate, thin plate theory. Now 16 mm has become a thin plate. So impacts will cause more grain coarsening because heat transfer is slow. And that will cause you failure in impact. Therefore, if you are qualified above 16, the lower limit is 16. Otherwise, you qualify below 16. Everything can be correlated to theory. Codes are extension of theory and simplification of the theory. So we accept that. How to check sensitivity and density in RT films? How to check? You tell me. IQS and densitometer. And how to calibrate densitometer?
Frequency.
How to calibrate, not frequency. Standard step wedge film. And your densitometer reading should be within plus or minus 0.05 of the stated density of the step wedge film. Then it is okay for use. What is the acceptance criteria of tube sheet joint? Pull out. How many joints need to be welded in tube sheet procedure? 10. You have to make a sample of 10. That's all in the code. So that you have to read the code. Is it necessary to do macro test of each section of TTS joint? Whatever is in the code, those sections have to be done. What is the percentage of expansion of carbon tube? Same percent, 3%, 5%. What is the testing requirement of the lip or hub of a tube sheet? What is a hub tube sheet? Do you know? This is the hub. You have to take a tensile sample as close as practical to the hub, and it should meet all the requirements of the material spec. Now, please note, this is the thickness of the sample, so this is through thickness test. So the steel has to be such that this is going to pass, otherwise it will never pass. It will fail in something or the elongation more than anything. So this is the additional requirement of hubbed tube sheet. What are the types of expansion? Meaning roller and hydraulic. What else do you mean? What is the question? Types of expansion. And
Lateral expansion or full expansion?
what?
Lateral expansion, full expansion.
I don't know. His question is what are the types of expansion? What are the minimum tests required to qualify tube sheet joint that we have done? What is the main difference between UW 51 and 52? What is it? I don't know. 51 tells you the method of doing full RT, and I think 52 is spot RT. Yeah. Spot RT. The spot RT requirements are different from full RT requirement. There is no porosity requirement in a spot RT. Any amount of porosity will do. Don't sell such a vessel to China. They will ask for spot RT. Over there, they will do full RT. Then they'll say, you missed so many defects. Now we won't pay you. Very crooked fellows. Though I know you have friends there, but impact test exemption clause of UHA material. Down to minus 196 materials don't require if they are a particular grade. Any weld metal, remember, UHA weld metal, if it has been subject to heat treatment, impact test is required. Keep that in your head solidly fixed. The moment I heat treat UHA weld, I must look and check for impact. What temperature UHA material does not exempt from impact testing? Now, what is the question? I don't know, but it may be minus 196 or something. Why is batch testing of consumable mandatory when impact test is applicable? It is not.
Sir, what is this UHA, sir?
Stainless steel, high alloy, UHA, high alloy. All the stainless steels that we know are under UHA, part UHA. It is part of the code as a number, part UHA. That way. Batch testing of consumables is mandatory when impact test is not applicable. Not that it's applicable. I'm not doing impact test, but I must check the batch that the material is meeting the impact test requirements or not. Then I can waive the mandatory testing of code of the production coupon if my consumables have been batch tested for impact. So the question has got some word missing. What is rolled normalized? Does SA20 allow the process of manufacturing? Yes, but it's not same as normalizing. Rolling normalizing is a separate process where the last rolling stage is in a normalizing temperature, but the property you get is part due to the working and part due to the normalizing. Whereas if you just take a plate and heat to normalizing and cool it, it is totally normalized. So 516 material is normalized and rolled normalized as being sold by Jindal and all these people is not meeting 516 specification requirement. But there are specifications in ASME which allow rolling normalizing, but not 516. If a welder test fails, can any retesting be done? Is there in the code, I think. Immediate retests are also permitted, provided whatever is the conditions. If 10 mm plate for PQR, what are the minimum bend test and type of test required? Go and read the code. If impact test is applicable on UHA material, what method of test for impact test shall be used? Lateral expansion. I must measure lateral expansion. How much the specimen is deformed before it failed or after it failed. Okay, so all your questions are answered. So now should be. Yes. Now tell about future. What, if anything, you require? This is done, this is done. For further development, I'm talking of your skills or knowledge. NDT is one thing I heard. Section 8. Section 9. Section 8. Okay, Section 8 because you all are not designing. So we'll talk general Section 8 about materials, about testing, fabrication, everything. So that Section 8 is a 2-day with lot of quizzes and lot of questions, and it's a very. Section 9. Section 9 also is 2 days, where we give you the WPS to fill up and make all the exercise, paper exercise of the documentation. So Section 8, Section 9 are two standard programs that are run for And then the NDT section 5, which will include hands-on. That will take more time because of the hands-on part. Yeah. Okay, so you talk to Mr. Wall and that is future date whenever you are free and willing to spend Saturday with me. Okay, gentlemen who are on the online, if you are still there, the program is over. Tata. I think no one is left.